If you've just joined us, we're live at Kuwait Earth Laboratory and about to make history.
10, 9,
Initiating launch sequence.
7, 6,
Good to go.
5, 4,
Launching Deep Earth Probe.
We're watching the first unmanned probe ever to penetrate to the center of the Earth and out the other side.
Probe data looking good. Distance from our position at the surface to the center of the Earth is 6,250 kilometers.
The probe is on its way.
Full power. Entering continental crust.
This is the part of the probe's journey into the Earth that we know the most about. The crust that forms the surface on which we all live.
Depth 1 kilometer.
Mostly sand and mud to start with. As much as half the living things on our planet are believed to live here, below the surface.
Now we're starting to detect basalt.
Basalt is formed from liquid magma. We often call it lava. That's reached the surface and cooled.
Switching to camera 2.
We can see lakes of undiscovered oil deep in the crust.
Picking up multiple gemstone formations.
Quartz is everywhere. One of the Earth's most abundant minerals.
Switching to camera 1.
There. That's magma rising into volcanoes at the surface. We're still in the continental crust. We can see it fracturing and faulting. The probe has now traveled deeper than any man-made borehole. Different types of rock are forming as pressure and temperature increase. Any second now we'll leave the crust.
Entering upper mantle.
We're through the crust. No one has ever seen this before. This is the upper mantle, an underworld sea of shifting rock, broken by inverted mountains projecting downwards from the crust.
The rock's not as brittle here.
No, it's more like a thick liquid, flowing very slowly. This is where molten magma originates, before it forces itself upward and into the crust, and starts to cool. The mantle, upper and lower, is almost 3,000 kilometers thick and makes up 84% of the Earth. It's solid rock, made up mostly of silicates. It's cooling and flowing incredibly slowly over geological time.
Engine data good. Tank pressures good.
Everything in the mantle is hot, dense, and under enormous pressure.
The probe's taking a bit of a battering.
That's the convection currents. They're what makes the continental plates at the surface move over geological time. Almost through the mantle. The rock has completely melted. We're in the outer core, a layer of liquid metal.
Outside temperature 6,000 degrees centigrade and rising. Visuals are breaking up. We're losing signal.
We expected this. Deep Earth is probing the inner core. Billions of years ago, the Earth began life as a ball of molten material. The heaviest, iron and nickel, became the planet's core. Since then, the Earth has been cooling from the inside out. The inner core is solid. It's about the size of the moon. We believe that it's growing a millimeter every year as the outer core slowly solidifies.
Standing by.
This is our longest wait.
I'm getting something. We're back in the outer core.
And traveling out the other side of the Earth.
Switching to full power for Earth exit.
I can see magma rising from the mantle ahead of us. We're back to the crust. It looks familiar, even from below. Giant tectonic plates moving against each other in a slow-motion dance. This is the oceanic crust, under the sea. A much thinner layer than the continental crust.
Depth 5 kilometers. Deep Earth is almost home.
And we've seen things that no one has ever experienced before.
Next stop, the Pacific Ocean.
We've done it. The first unmanned probe through the center of the Earth. And Deep Earth is back on the surface.